Hello everyone, my name is Peter Kelty. I'm a software-defined systems engineering manager for the East Coast, and I also am a member of the Office of the CTO Global Field focusing on storage. I have been with VMware for about 4 years. Prior to the release of the vSAN product, I've been lucky enough to speak to many customers, seeing us grow from 0 to 10,000 customers today. And I get asked a lot of questions, so I thought today we'd focus on one of the questions I get asked frequently, which is, hey, I have my vSAN up and running. Now, how do I get workloads migrated onto vSAN? So over here on the right-hand side, we have our vSAN cluster. We have our vSAN Datastore, all newly created. We've leveraged the local disks in the host to create this pool of capacity to become the vSAN Datastore, which virtual machines in that cluster can consume. On the left-hand side here, I've got my existing environment. For sake of argument, let's go with an environment that's a typical fiber channel setup. And yes, there's going to be redundancy in fiber channel, but most fiber channel environments are going to have some kind of switch fabric, multiple switches per chance, and one or more storage arrays. So all these hosts are connected in some form through the switch to the storage array. In order to present my data store, I create a LUN, and when I have a virtual machine, let's say a VM running on this host, VM number 1, we'll say that VM number 1's data is sitting on the LUN that's on this storage array. Okay, so this is our setup. We've got the VM with its data sitting on this storage array. How do I get this VM migrated onto the vSAN Datastore? Well, of course, we're going to need a network to do that. So all these hosts are going to be connected to hopefully a 10 gigabit Ethernet network for virtual machine traffic. So this would be your VLAN for your virtual machines, maybe vMotion, other workloads. We're also going to have a VLAN for vSAN traffic. All right, so the nodes in this cluster are going to communicate and send data across the VLAN for vSAN for internode communication for the vSAN Datastore. But virtual machines, if I need to move a virtual machine to this network, it's going to be done over the virtual machine network for the most part. But let's talk through some of the scenarios. All right, I've got my VM, I've got the data on this host. How do I get this virtual machine over to the vSAN Datastore? The first option would be backup. So I have some backup server connected to this network. The virtual machine data could be pulled through the virtual machine, up through the network to the backup network, and then across the network again, down to this host, and restored on this host, or any host in that cluster. And yes, and if you have a fiber channel network, it's possible that maybe the data will flow because of offloading directly from the storage array itself through the SAN over to the backup server. And then that backup would then be used to restore that virtual machine to the vSAN Datastore. So backup is one of our options. It does require hardware, right, in the form of a backup server. It does require downtime. In order to do this migration, I back up the virtual machine, I shut the virtual machine down, I restore it over onto a new host in the vSAN data store. Can I test this ahead of time? Well, yeah, you can shut it down, you can bring it up in this environment and test it. And if everything's good, leave it there. If it's not good, then I can fail back by shutting this virtual machine down and powering this virtual machine back up. And so that would be my form of failback. All right, so backup, not very interesting, but it is one way to do this. The one most people are going to think about is vMotion. So of course, we can vMotion. As an option. But the challenge is, how does that traffic flow? Well, the vMotion traffic is going to be, it's going to be initiated through Virtual Center. So we have, let's say, a vCenter VM running here. Through vCenter, we're going to orchestrate the movement or the vMotion of that virtual machine, and we're going to vMotion both the virtual machine and its data together in one vMotion action, to where the data gets pulled from the storage array, the whole VM is packaged up with its data and migrated over and down to, again, any host in this cluster. So this is what's actually correctly called vMotion cross cluster, otherwise known as XVMotion. All right, so XVMotion is the action of moving a virtual machine and its data from one cluster over to another cluster. Now there's some advantages to this. There's no hardware required. It's just leveraging the existing hardware that we have. There's no downtime for the virtual machine. It's moved live without downtime. But can you test it ahead of time? Well, not really. You're moving that VM over to the vSAN data store. Sure. So there's not really any way to test this. You're just going to move it. If you like it where it is, great, leave it there. If not, you can fail back by essentially vMotioning it back to the other site. So, a couple of advantages of vMotion and maybe one or two disadvantages there. This is also, I guess, worth mentioning that this cluster can be on the same network in the same data center. We could have a WAN in between. So this could be another data center. If that's the case, this vMotion activity is actually called a long distance vMotion. And I know I'm running out of space on my box here. Or this could be VMware Cloud on AWS. So this could be your cluster out on AWS. So that's another option here, is we could be vMotioning data to AWS. And then the last is you could have, if this is another data center, you could have a different vCenter over here as well. You could have a different vCenter running, and you can do cross vCenter vMotion as well. So those are all different vMotion options that you have at your disposal. One thing to note here is that depending on the size of the virtual machine and the amount of capacity in this virtual machine, it could take a fair amount of time. Again, if you're going across a WAN, it could take a fair amount of time to get that virtual machine and its data over to the other cluster. If it's local, of course, with 10 gigabit bandwidth, it'll take a lot less time. All right, so let's move on to the next. I often get asked, can't I just storage vMotion my data from the cluster where my VM is running over to the vSAN data store? And the answer is you can, but it does require additional configuration. what you would need to do is you would need to implement an HBA, a host bus adapter, on at least one of the nodes in the vSAN cluster, connect that back to the switch so that I could then say, okay, let's give this host, which has an HBA connection through the switch, access to this LUN, and then I could move the virtual machine first from my existing host on my existing cluster across the network and land it, let's say, on this host. Actually, yeah, let's, I know this is going to smudge, but let's move the HBA over here. All right, so now this is going to be my HBA with my connection back to my SAN. I could then, after the virtual machine is moved over, I could then go and move its data, since this virtual machine now has access to the vSAN data store and access to its pre-existing data store. I could then do a storage vMotion of that data across the virtual SAN network through this HBA, and then have it land on the vSAN data store as my virtual machine 1 data. Okay, so that's another option. Storage vMotion. So in this case, is there hardware required? Yes, we do require fiber channel HBA. Is there downtime? No, there is no downtime. Can I test this up front? Well, similar to vMotion, I'm actually moving the data, so I guess I can move the VM and test to make sure everything's good, and then move its data and test to make sure everything is good. But for the most part, there's not a pre-test that I can do ahead of time. And then can I fail back? I guess so, yeah. I could always move that VM back if I didn't like it once it got over there. Or I could storage vMotion the virtual machine data back if I wanted to do that. So there is some form of failback in that case. All right, so those are all great examples of using the power of VMware and vMotion and storage vMotion to move your virtual machines. There are some drawbacks, and I want to highlight the advantages of being able to test the failover and the failback before you do a migration. And this is where Vsphere Replication comes in. And so with Vsphere Replication, I am going to stand up a Vsphere Replication virtual machine on a host in the cluster here. I'm going to, through vCenter, orchestrate the replication of a virtual machine and its data from the existing data center or the existing cluster. Again, all the data will travel up, packaged with a virtual machine through vSphere Replication, travel across, and land down on one of the hosts in this cluster, and the data will be written to the vSAN data store. So vSphere Replication handles that. If I then want to bring the virtual machine up, I'm going to have to shut this virtual machine down and then come over here and through vCenter power on this virtual machine. I have its data. I can just power it on in one of the nodes in this cluster. So with vSphere Replication, there is no hardware required. There is going to be downtime. You are going to need to shut this virtual machine down and then power it back up over here. So yeah, yes, there's downtime. Can I test it? Yes, I can test this. So I can power the virtual machine down. I could bring it up over in this environment, test it, make sure everything's going well. And if it is, leave it there. If not, I could say, you know what, things aren't good. I want to shut it back down, and I'll power it back up. So yes, there is a failback capability with vSphere Replication. All right, so that's one virtual machine. A lot of customers want to be able to migrate multiple virtual machines at the same time. And so with vSphere Replication, we can also include SRM. So let's include an SRM virtual machine on site A, and another, I'll draw it up here, SRM virtual machine over here in the cluster that I'm trying to migrate to. And then through SRM, I can orchestrate the ability to migrate a workload, and not just one virtual machine, but maybe multiple virtual machines. VM2 and VM3. And over here, I'll have VM2 and VM3 data. And so through Site Recovery Manager, I can then say, okay, I want to orchestrate the movement of all three of these virtual machines together with their data. So I make sure vSphere Replication is synchronizing their data. And then through through Site Recovery Manager, I can say, when I move these virtual machines, I'm going to power them off in order. So maybe I power off virtual machine 2 first, and virtual machine 3 second, virtual machine 1 third. And then I move, and then over on this side, when I power them back up, maybe I want to power up virtual machine 1 first, and I have its data, and then virtual machine 2 maybe comes up second, and virtual machine 3, virtual machine 3's data would be replicated through Site Recovery Manager, and I can power up virtual machine 3's data, all in a nice orchestrated fashion, so that maybe the database server comes up before the app server, which comes up before the web server, something like that. So the option here, vSphere Replication plus SRM. The benefits is, no additional hardware. No, there is downtime. So yes, there is downtime. But most importantly, I can test this. So through SRM, through vSphere Replication, I'm going to have the data replicated. Through SRM, I can actually test and bring up this environment, my vSphere 1, 2, and 3 environment, up in a way that it's in an isolated test environment. I can validate that everything's good. And then when I'm ready, I can say, okay, I want to do the actual failover, and click the magic button, fail over this whole environment, shut these VMs down, bring these VMs up, knowing that I've already pre-tested this, and I'm able to do this in a nice, consistent fashion. The last column I have here is consistency groups. Consistency groups. I know that didn't write very well, but vSphere Replication and SRM can deal with consistency groups so that I can group these VMs together, have their data replicated, keep them in time sync, and bring them up in a nice, orderly fashion. There are a number of other third-party solutions out there in the market. Some require additional hardware. Some can do it with virtual machines. So most are going to require downtime to shut down this environment and bring this environment back up. Some offer pre-testing and failbacks, and can deal with consistency groups. So there are some third parties. The benefit of vSphere Replication and Site Recovery Manager is vSphere Replication is included with vSphere licensing for the most part, at least with the advanced or with the enterprise licensing. And Site Recovery Manager is an additional add-on product, but it's a tried and true and tested method for migrating virtual machine workloads. Okay, so in summary, I want to point out that there are a lot of options to move your data from your existing cluster over to your new vSAN cluster, some with downtime, some without downtime, different advantages of each. So I just wanted to point out the different advantages. I'm a big fan of Vsphere Replication and Site Recovery Manager because of the ability to pre-test this in a nice orchestrated fashion. Some may choose vMotion or something like Storage vMotion if they're willing to put fiber channel HBAs in their hosts. I don't see a lot of customers doing that. So probably the second most popular is going to be the vMotion method to move the workloads. By the way, just like vMotion is able to be done between clusters across WAN, so this could be another data center, vSAN another data center. It could be vSAN stood up in VMware Cloud on AWS. Vsphere Replication and SRM can work equally well in that as well. So you can, again, set up Vsphere Replication, replicate to your DR environment. And then the other benefit to highlight this option in that WAN environment where the vSAN cluster is in across the WAN is that I can pre-stage the data before I actually do the failover or the migration. So in other words, I can have Vsphere Replication, replicate the data, make sure it's residing over here in the vSAN Datastore, and then when I'm ready, click the magic button to say failover. Yes, I am going to have a slight amount of downtime to shut these VMs down and bring these VMs up in this environment, but the data's already there. So I just bring the VMs up in this environment and away we go. The downside of vMotion is if this is terabytes and terabytes worth of data, I have to wait for vMotion to finish, wait for the storage with the virtual machines to get migrated over, and wait for the data to get in sync between the two sites and all the commits to be committed on the secondary or the other cluster here, and then I can flip the switch and cut over to those VMs with vMotion. So again, it's supported, it can be done. I do prefer or highly encourage the Vsphere Replication and SRM method for doing this. All right, I hope that helped paint the picture for the various options. I thank you for your time today, and go vSAN.